Hello, welcome back to Build Succeeded. My name is Lucian and this is the fourth video in the 3D Engine series. Today we are going to implement cameras and triangle clipping. If you haven't seen the first 3 episodes of the series, I suggest you go back and watch them, as we're going to continue from there. I've added the links to the description. Cheers! After I implemented textures in the previous episodes, we now have a textured 3D cube rotating around. But a game is not a game if you cannot look around. That's what the camera is for. If you remember, in the previous episodes, we were always projecting stuff on the screen with the center of the screen being at 0, 0, 0 and always looking along the z-axis. But what if we want to look at our cube from over here? That means the camera, or the eyes of the viewer, have a different position and direction than the center of the world. The easiest way I found to implement this is, instead of looking and rotating the camera, we will instead move and rotate the world in the opposite direction. I'll start by adding a camera class. The camera will have a position and a rotation. I'm also adding a few methods to the class. Let me explain them. I'm adding 2 constructors to the camera. One where the camera is set in the initial position, center of the world, and the other where the camera receives an initial position. Now, handle key up and handle key down are 2 methods that will set a few variables depending on the keys we press. After that, we have the logic method, where we control the camera in a very simple way, based on what keys are pressed. Up and down will move the camera forwards and backwards, and left and right will rotate along the vertical axis. The reason I'm separating the camera logic is that I might want a different type of camera in the future, and now we have all the code for the way it moves in a single place. I'm going to add a camera to the engine base class. That also means I'm going to initialize it in the constructor, call the handle key down and handle key up methods when keys are pressed, and call the logic method. To make sure I don't forget to call the base methods when I use the engine class, I'll override the key down and key up methods now, the same way I did with logic. In the triangle class, I now need a new set of points. If you remember, we had the points variable for the triangle points relative to the object center, world points, which were the triangle points relative to the center of the world, so taking into consideration the object's position and rotation, then draw points, which were the triangle points after applying perspective. In between world points and draw points, we now need camera points, which are the triangle points relative to the camera. We also need to add a new method called calculate camera view, which is going to translate and rotate the triangles based on the camera position and direction, but in the opposite way. We're also going to move the average z calculation in this method, and then change calculate draw points to use camera points instead of world points. Now the draw method in engine base will also call calculate camera view on each triangle, right after calculate world points. Okay, let's stop the cube from spinning so we don't get confused. And let's run the application. Now I'm pressing down, which will take me further away from the cube. Now I'm pressing up and we're approaching the cube. Let's press left to look left. Oh god, this is not good, is it? What if we get closer? Oops. It turns out our algorithm is trying to write outside the screen, because as we get closer, the cube is getting out of our view. Let's temporarily add this condition in to test out. We're going to remove it after we implement triangle clipping. If we run it now, we can approach as much as we want. Well, not really, apparently. It now looks like the FPS is getting smaller and smaller, and yes, now it just stuck. This happens because as we get closer to the cube, the triangles will appear bigger and bigger, and our algorithm draws pixel by pixel, which means the number of pixels might get into billions. So let's implement triangle clipping, which is when we cut the part of the triangle that is outside the screen. We usually have 4 situations. The first is when the entire triangle is inside the screen. This is easy, we keep the triangle the way it is. The second situation is when the triangle is completely outside of the screen. This is also easy, we simply don't draw it. The third situation is when the triangle has 2 points outside of the screen. In this case, we need to find these 2 points that intersect with the screen edge and then build another triangle using these 2 points and the point inside. The fourth situation is when the triangle has just one corner outside of the screen. In this case, we find the 2 edge points, but now we have a total of 4 points, so we cannot form a triangle. So we will form 2 triangles. This is 1 and this is 2. We need to do this against all 4 edges of the screen, in case we have a triangle that is like this. In this case, we can do it against the left side first, which will result in 2 triangles. Then cut the upper side, then the bottom side. In the end, we will end up with 5 triangles that are all inside the screen and ready to draw. Let's start with the triangle class. We're going to clip triangles after applying perspective. If we're going to create new triangles that far in the rendering pipeline, I'm going to update the constructor to set the camera points and draw points as well. This is not going to affect the calculations, but it's going to help us copy triangles right before rendering. After a couple of getter methods, I'm going to implement getClipTriangles. This method will return a list of triangles after clipping the original one. So let's first create a list of triangles and push in it this triangle. And I'm also declaring a few variables to help me out. Let's first handle the left side. To return variable will work as a queue. We pop triangles from the beginning and push triangles in the back. So after extracting the first triangle, I'm going to count which points are inside and which are outside of the screen by comparing the x coordinate with 0. Then delete the triangle to avoid memory leaks. Now to handle the 4 situations. If all are inside, we push the triangle back into the queue. If there is one point outside, we calculate the 2 intersection points, then push back the 2 new generated triangles. If 2 points are outside, I calculate the 2 intersection points, then push back the new formed triangle. We don't need to do anything for when the 3 points are outside the screen. We're going to do the same for the right side, then for the top side, and finally for the bottom side. Now to use this method, I need to go into Engine Base class in the draw method, and instead of calling draw on each triangle, I'm going to calculate the list of clipped triangles and draw the result. Let's see what we got. We can now get closer without the fear of losing FPS, because the triangles are now clipped and the code doesn't write outside the screen anymore. Well, we still have a problem. As we get closer, we should pass the cube, right? It should be behind us, but we can still sort of see it. That is because the perspective never takes into consideration where the triangle is, and it can be behind the screen. So we need to clip the triangle along the z-axis as well. The z-axis clipping needs to be done before projection, so we cannot include it in the same method. Let's create a new method on the triangle class called getZClipTriangles. This new method will work very similar to the other one, with a few exceptions. We're comparing against the z-axis, we are using camera points instead of draw points, but more importantly, we now need to make sure we preserve the clockwise order of the new triangle points to face the same direction. That's why we have this part right here. Now back to the Engine Base class. In the draw method, instead of pushing the triangle in the all triangle list after calculating camera points, we also call the new clipping method and add those resulting triangles to the list. We also need to make sure we delete the new triangles to avoid memory leaks. I think it's now safe to remove these conditions from the triangle class as well. I'm sure it won't try to write outside the screen anymore. Here it is. Even if we go forward, at some point the cube will disappear, as it's moving behind the camera. Okay, so we have a camera now, and clip triangles. In the next episode, I will add lighting to the engine, and then we'll try to load Blender models. Subscribe if you want to see the next videos and give me a thumbs up if you like the video. Thank you for watching and see you soon.